Welcome to Natural Habitat Adventures Daily Dose of Nature. Today's topic, elephants, trees, and bees. What's the connection? Presented by NatHab Expedition Leader, Lorraine Doyle. I'm your host, Rob Bess. Thank you all so much for being here today. Over to you, Lorraine.
Awesome. Thank you so much, Rob. I'm really excited to be presenting this. As I was explaining to you a little bit earlier, this is something that it's a whole series of or group of creatures that I'm really passionate about. So I really hope that I'll be able to share something that I have just found so incredibly amazing. So as you said, unfortunately, my bandwidth doesn't support our webcam. So just in case anyone who doesn't know me, that's a picture of yours truly. So we'll now go to the main protagonist, if you will, of this discussion, the African honeybee. Sometimes known or referred to as killer bees, which in my mind, whilst it is truthful, they really have to be provoked to an extent to become that dangerous. So when they swarm, they can be exceptionally dangerous. And as a result, that I think in some ways has given them a little bit of a bad reputation. But they truly are incredible creatures. And at some point, if I'm privileged enough, I'd actually like to give maybe a presentation just on bees alone and their social structures and just so many of the amazing things we can learn from them. So all of the bees that actually are workers that you can see a lot of here are all females. So the drones basically, their only function is mating. They actually are fed by the worker bees, and so they really have a very limited role. So that's the one actor, if you will, in this production. Then we've got a couple of others, which are a little more inanimate, if you will. So this is a marula tree, known, its scientific name, Sclerocaria borea. Basically, scleros means hardened and carrier means case, if you will, or seed covering. And it refers to the hard nut that contains the seed. For those of you who have been to Africa, there is a liqueur called amarula cream, which is very nice. It's a lot like Bailey's Irish cream or one of those. And that's made from the fruits of this tree. Elephants also love these trees. They love the fruit, they love stripping the bark, they love the roots, particularly in the dry season so that they can get moisture. And so elephants, unfortunately, can do a lot of damage to these trees, especially these big mature trees. And I'll explain why that can become a real problem just now. So this is another tree that the elephants are very partial to. So Senegalian aggressans, or the knobthorn. It's called a knobthorn because it has these little bumps all the way up the trunk and the branches, which are all armed with prickles that are there really as a browse protection, but it doesn't generally deter elephants. So elephants are also very happy to strip the bark, push over the trees, and just generally do quite a lot of mayhem. Now, one of the problems is that these large trees are very important for nesting sites for things like vultures. So vultures in most parts of Africa are actually endangered as a result of habitat loss, farmers using poison, poachers also using poison because vultures give away the location of a potential carcass. So when you then add the knocking down of these big trees, removing their nesting habitat, you now create another paradigm, so to speak, of them not having what it is that they require to survive. So that's why we're very concerned as conservationists about conserving these big trees. So the third portion or actor in this is the African elephant itself. I didn't include another picture here because I think it's an iconic enough animal that it's well known to everybody. It's called Loxodonta africana, which basically means slanted tooth from Africa. That's a literal translation. And obviously the slanted tooth refers to its tusks, which it uses a lot. They will use them to pull grass across, to break grass that they're eating. They'll use it to strip the bark in the dry season to get to the cambium layer, which is where all the nutrients and moisture are under the bark of the trees that they favor. So yeah, that's basically how they're, obviously Africana, because this one specifically comes from Africa, unrelated to the Indian elephant, and obviously very different, much bigger, and also not tameable, in inverted commas, in the way that Indian elephants have been. So this is just a little showing you of what elephants do to trees. So the one with the actual elephant in the picture, that's what we call debarking or ring barking. In this case, that's really severe. So this elephant has removed all of the bark from that tree and removed all of the cambium layer, so all of the xylem and phloem, which contain the water and nutrients, have all been stripped out of that tree. So that tree will now die. The top picture shows where they've basically broken over, they've pushed it over, sometimes just because they can, if it's a bull elephant and must, otherwise because they want to get to some of the juicy leaves at the top, and it's just much easier to push it over than it is to stretch up to reach it. And then the bottom one is where they have uprooted the tree. So this was to get to the actual roots. And again, water, nutrients in those roots. And they'll literally, you can see these are quite freshly pushed over. I took these photographs 2 days ago, and they haven't browsed any of the leaves. They just took what they wanted. You can see the white bits on those roots that have been stripped, and they've just gone off on their merry way. So quite destructive in that regard. So how do we traditionally protect trees from elephant damage? Well, there's a number of ways that have been done historically, both of which have a level of effect. So the first is to take mesh wiring and to wrap it around the entire trunk of the tree, up to a height of about 2 or so meters. And what this mesh does is it stops the elephant from being able to get its tusks in to actually debark the tree. Sometimes, though, the elephants just get mad at this, and so they push the tree over, or they'll reach up and break branches above the level of the mesh. So it's partially effective, and it's certainly better than nothing, but it's not perfect. And then the other that has been used where you have access to huge rocks is elephants don't like walking on rocky surfaces. And so if you put rocks in a big enough radius around the base of a big tree, then it will stop them getting close enough to actually be able to do damage. But if you're in an area where there are no rocks, some of the areas in South Africa are very sandy, you're not going to find boulders like that. So that strategy is not going to work. And that's really the methods that we've had until the early to mid 2000s. And then some research has found that bees can protect trees. And So this is essentially the link that I'll talk about now about elephants, bees, and trees. So elephants are terrified of honeybees. And that seems like an incredibly strange thing, because here you have the largest of all the land mammals and you have these tiny little insects. And yet elephants are actually really afraid of them. And the reason being is that although their hide is incredibly thick, they have a lot of exposed sensitive areas. So areas inside the trunk, the eyes, actually behind the ears, and even on their belly. Those exposed areas are very, very sensitive. And so elephants don't wish to be stung because not only is it painful, but now if you have a situation where swelling occurs, particularly in the trunk or the mouth, then obviously breathing can become a problem. So that's why elephants are afraid of honeybees. So the next question that seems logical to ask, well, how do we prove this? And how do we use it to protect trees? And there's been a number of studies done. So one, fever trees, which was done back in 2002. And then one which was actually recording honeybees by Lucy King in the mid-2000s. And then beehive fence lines, which also was Lucy King's work, which has been ongoing. So what Ian Douglas Hamilton, and I can't remember what Volrath's first name is, but they were finding that they were speaking to herdsmen in Kenya and finding that where there were trees that had wild bees in them, the trees were unharmed. And yet where there were no beehives in those trees, the elephants were pushing them over. So what they did is they then took beehives. They used not the ones like I had in the picture, but more traditional log-shaped ones, and they put them into trees. And then they had a control group where they had none. And to their amazement, what happened was the trees that had none were damaged exactly as had been described to them, and the ones that had hives had not. So they deduced from this, well, okay, clearly there's something in this. So elephants steer clear of this. So then a little bit later, Lucy King from Oxford University in England came along, and they said, okay, well, let's see, is there anything to the sound they make? What are the elephants actually reacting to? So they did some potentially quite dangerous research. I don't believe that it was unethical. But what they did was to try and get the angry buzzing of a bee when it's agitated and disturbed. They actually, into one hive, put a rock and waited for the bees. And lo and behold, the bees started going crazy and making a very, very specific sound. And also they release a very specific pheromone. A scent, if you will, that also incites others in the hive to start swarming. So that will become pertinent a little bit later. But so from that, they took those recordings that they had, and then they played them back to a number of groups of elephants. And lo and behold, the elephants took off. They were not at all happy about this. So much so that further work that Lucy King did was to look at, do elephants have a specific rumble for bees? So most elephant communication we don't hear. We only hear a very small portion. A lot of their communication is ultrasonic. But what they detected was that there is a very specific rumble that elephants make when they encounter bees. And it's basically like, okay, guys, let's get out of here. This is not a good place to be. We're not sticking around. So then what she did was they were experiencing, so this work was all done in Kenya. They were finding that there was a lot of elephant-human conflict. So farmers were having their crops raided by elephants, and people were getting injured as well in the process. And none of the traditional fences and other things seemed to be working. So what she did was, she said, okay, well, so the bees, the bees need to become agitated. So because of that, let's find a way of possibly suspending them from fence lines. So that's what they did. Maybe. So that's what they did. So they created these rows along the edges of croplands, and they hung these hives, so that's shade that you can kind of see over the top of them, that sort of straw or thatch. And then what would happen is the elephants would come along, they would knock the fence, the elephants would go, the bees would go, hey, who's shaking us? We don't like this. And they would start buzzing and swarming, and the elephants would take off. So that was how this work originally started. And as time went by, they found that elephants are so intelligent that over time you can find that they will just respond to a hive just by seeing a hive if they've already been sensitized. You don't always necessarily have to have the bees. Also, they discovered more recently that you can, and they're trying now to replicate synthetically the pheromone, the attack pheromone of bees, so that they can then utilize that in areas where perhaps beekeeping is not appropriate. And just by planting the scent of swarming bees, the elephants will stay away. So how does this relate to trees? Okay, there's no trees in this at the moment. So how do we extrapolate this whole process? What do we do? And so what happened was the work that had been done by Ian Douglas Hamilton and Lucy King and others in Kenya, the work was taken up here by Dr. Michelle Henley and one of her PhD students, Robin Cook. And what they did was they found an area that had recently been opened to the Kruger National Park, but it had had no elephants in it for the last 30 to 40 years. And now the fences were coming down, and so these trees were now going to be exposed to elephants. So what they did was they took 150 adult marula trees in about a 30-hectare site. And then what they did was they created 3 groups. So they had 50 trees that they put beehives into, 50 trees that they put wire netting onto, and 50 control trees. And so the control trees essentially had no protection at all. They were just left standing. And so there was some other criteria that they had to observe based on Lucy King's work. Trees needed to be approximately 7 meters apart, and then also put them a long distance from residential areas, because obviously you don't want bees swarming where you don't have to, too close to people. So those were the criteria of how they selected the trees they were going to test this on. And so I know these are not the greatest images, but you can see there's an elephant approaching this tree. And normally what would happen as they will watch these elephants is the elephants would then normally approach the tree, come up towards the main trunk and start pushing it or trying to feed or break branches. But what they found is as soon as the elephants got close and they heard the bees buzzing, they would start to walk away. So they didn't actually necessarily always even get to a conflict situation whereby they would shake the tree and cause the bees to swarm. So they were actually reacting to the sound that they were hearing and decided that, yeah, this is not a good idea. We're out of here. So I know most people, when you sign up for these things, don't expect somebody, I'm sure, to come along with graphs. But this is just really, really interesting because what they found was statistically really significant. So if you have a look at this, this was the number of impacted trees. So this was a longitudinal study. It was done over 6 years. So they left, there was a lot of time to gather data and to make sure that as far as possible, what they were observing was actually based in fact and wasn't just artifact. And so as you can see from this basic bar chart is that if you look at the control group, out of the 50 trees, about 27 of them were severely impacted in some way. So that's either they were pushed over, they were ring-barked, or they were otherwise substantially damaged. If you went to the wire netting, the wire netting provided some protection, certainly. So you only had about 15 or just less of the trees out of the 50 being impacted. But there was still a fair amount of impact. And then you went to the ones that had a beehive, and basically one tree was affected. And in some literature that Robin had put out, he basically indicated it was because the bees had pretty much absconded from the hive for some reason and more or less left the tree unprotected. So stats, damn stats, but no lies. So 54% of the control tree group were damaged in some way. So more than half had, when they talk about damage, they're not referring to just a broken twig here or there. They're referring to the kind of damage I showed in those earlier pictures. 28% of the wire-netted tree group were damaged in some way. Often, if it was just branch breaking, it was less severe, but in many instances, it seemed like the elephants got annoyed and they pushed the trees over, just because, again, because they could and they weren't getting their way. But only 2% of the beehive group trees had any sort of damage. So from this, they deduced essentially that it really is something that works. So now, not only do you have a situation, if you apply this correctly, as they did in Kenya with the fences, but if you now are to take this and say, okay, well, not only are we able to protect the trees, but what if for local communities who live on the borders of these parks, who may or may not be being directly impacted by elephants, but certainly are being impacted by having conservation areas on their borders, what if we get them involved in beekeeping? So if we get them involved in beekeeping, then through that, they can then start to harvest honey, and they can sell that honey. And through selling that honey, they can then make an income. So now conservation starts to pay. So not only are they, as a community, not experiencing so much elephant-human conflict, but they are also being able to actually make something of a livelihood out of it. And so what Michelle and Robin did was pretty much the same thing, and they started with the local communities in the area, actually funding the initial hives, the equipment required, to actually become an apiarist, and they then started bottling and selling the honey, and the money was then going back into the communities. So these are the kinds of projects in conservation circles that we are trying more and more to look at, because it's starting to create a win-win type situation, not only for the animals, but also for the humans who are being impacted by having these conserved areas. So this is just, I don't know how much maybe some of you know about beekeeping and so on, but I have a hive of my own, and then where I'm based, we have a number of hives. And we've done this for a few reasons. One is sure to harvest the honey, but the other is because honeybees are also so endangered. We're not necessarily 100% sure why their population numbers are in such decline, but they are worldwide. And obviously that becomes a significant problem for us because many of our food crops are bee pollinated. And so not only are we looking at bees in terms of maybe mitigating human-wildlife conflict in rural areas, possibly in our conservation areas, looking to protect our trees, but also in the bigger conservation picture, looking at how do we maintain or try and promote global biodiversity. And as I was saying to Rob just before we started, biodiversity conservation is, if you like, the new buzzword. No pun intended, sorry. But so essentially what we used to do in the 20th century is we had specific species conservation. So we would look at the elephant and say, we need to conserve the elephant at all costs. And it doesn't matter what happens to the rest of the ecosystem, we need these large iconic animals. And tragically, as a result of that, what we started to see was what we call ecosystem crashes. And that's because if you think about the damage an elephant can do to a tree, you then start to have all those knock-on effects, not having roosting sites for vultures, other creatures that live in those areas. If you now get really high concentrations of elephants, they can do a lot of damage. And so how do we now start to look at the entire picture to try and maximize it for all the species concerned? And this is where projects like these bee-type projects are starting to see how do we address the problems that we are facing or the challenges we are facing on a multiplicity of levels. It's quite interesting to look at when you're talking about conservation issues. It's very easy to actually become quite pessimistic about it because the problem seems so big, and people tend to get start to get pessimistic and like, oh, well, there's nothing we can do about it. And I don't believe that at all. I think if we engage our brains in meaningful ways, then we can certainly make big differences to conservation, whether it's just by keeping bees in a beehive. It's not something that you have to be doing in the wilds of Africa. And so that's why these creatures, for me, are just so amazing. So I actually generally don't harvest the honey out of my personal hives, because obviously bees store honey to consume it for themselves. So it's there for the tough seasons when, the going gets tough, if you will, and they've got additional food sources. Now, what you can do is you have what we call your brood chambers, and then you have things that you put above those called supers. And those are the ones where you can harvest the excess honey. But as you can see, this is a very busy beehive, and the strange looking alien in the picture is me. So I know that it's actually been a bit quick. It went a bit quicker than I thought it would. But if you're interested, I can talk a little bit more about the research work that was done and the hives and so on. Or I'm more than happy to answer questions that people may have. So I don't know, Rob, how you would like to handle it.
Well, thank you, Lorraine. I think we'll go ahead and we'll get you some questions so that we can answer some of the questions our guests have.
Okay.
But before we start, I just would like to remind everyone that you can submit your questions via the question field in your control panel. With that, we will get to some questions here. Can you talk about the difference between a honeybee and a killer bee, and can a killer bee produce honey?
Yeah, so thanks, Rob. So essentially, the killer bees are actually African honeybees. So essentially, they got the name because when they swarm, and they are generally more aggressive than Asian bees. So they tried this kind of work in Asia as well, because they also experience human-wildlife conflict. And it was less successful because the Asian bees are much less aggressive. And Robin actually tells a funny story of, you can see how we go kitted out to touch bees. But when he was in India and they were doing work there, he said it was quite amazing to see that these guys would go and handle things in the hives without even gloves on. They would literally walk up to them and pull the frames out and carry on working. And the bees would be buzzing around them, but wouldn't actually do anything. If I wasn't protected by that alien suit and those ridiculous looking gloves, and I was going into these hives, I would potentially be in serious trouble. And it's not, they're only responding as any animal would to their home being, for want of a better word, invaded. And so it's just the nature of our bees in Africa that make them, if you will, aggressive. It's just however they've evolved, that's how they've evolved. And Asian bees have evolved less so. What's also interesting, and this is an aside, is that obviously honeybees are highly social. They live in these enormous hives. They have what we call segregation of labor. So they have workers, they have drones, they have the queen. So there's a whole system that they have in place. But most bees are actually solitary bees. So if you think about carpenter bees or your typical British bumblebee, and a whole variety of others, those are all solitary bees. So they don't live in these kind of environments. In fact, more wasp species than bee species actually are as highly social as this. But yeah, so that's what a killer bee is. It's an African honeybee. It's an Apis mellifera bee, as opposed to, and I'm not sure what's exact the species of Asian honeybee is. But yeah, it's just the species. But,
great, thank you for that. Now, if there are a large number of trees that are being protected, are there sufficient alternative sources of moisture and nutrients for elephants to eat? What else are they eating otherwise?
So, yeah, it's a very good question. So the trees that we're seeking to protect are what we call large trees. So those are the trees, because trees in Africa are very slow growing. We don't have a lot of fast growing trees because many of our trees are hardwoods, and hardwoods take many decades to reach maturity. So those are the trees that you're wanting to protect. And maybe a few of the kind of medium-sized trees. So because the trees obviously are fruiting and there's seed dispersal, there's new trees coming up, those trees are obviously available. The other interesting thing is that elephants are primarily grazers. They're primarily grass eaters, not tree eaters, not browsers. So in the height of summer, you will, for the most part, you will see elephants consuming large quantities of grass. So much so that elephants, which an elephant can be right or left tusked, just like we are right or left-handed, so they'll use one more than the other, but they will actually have a notch on one of their tusks, which is where they pull the grass across to break it. And so a large percentage of their diet comes from grass. It's only in the dry seasons when the grass has lost its nutritional value that they then switch to being more of a browser. And obviously we would make sure that there will be sufficient browse for them during those times. So you're really trying to preserve your large iconic trees. So the smaller ones, you're going to quite easily be able to sacrifice a percentage of those to elephant consumption, while still recruiting enough to make sure that you have older trees going forward. So that's really the way that this whole process has been managed, is let's protect the big ones that we've got so that we can maintain our nesting sites for vultures and other raptors, but also make sure that there is browse available to elephants.
Can you talk about what the bees live on? Are they consuming the trees, the same trees as the elephants? Can you give us some clarity on that?
Yeah, so the bees will forage from a large variety of different plants and trees, anything basically where they can obtain pollen or nectar from. So it's quite interesting. The honey that we get early in the season is very, very different in taste to honey that we get later in the season. And that's because the bees utilize what is flowering at the time. So our early season honey often contains, the knobthorn is actually one of the first trees to flower. So they'll utilize that. There's another tree called a weeping boerbean. They utilize that. And they may even, for the first kind of batch, if you will, of the season, still be using some of the aloes that flower in the winter. So we would never harvest in winter. We only ever harvest if we are harvesting honey in summer, because obviously the bees need the honey to sustain them through winter. And that's why you only ever remove a percentage, and only in summer. So they will then, and they can forage up to several kilometers. They will go out looking for pollen and nectar sources. So yes, some of them may be the same trees that the elephants are feeding on. And elephants and bees will happily coexist, provided that the elephants don't agitate the bees. So they can coexist side by side. It's just a case of if the elephant is shaking the tree, and for anyone who's ever seen an elephant shake a tree, I'd also be mad if that was my house. And it's that actually precipitates the swarming, which then enacts a protection of the trees. So the bees have access to many, many different sources. flowers obviously as well. But yeah, that's kind of how they, if you will, how they coexist, and how bees also will utilize any other sources they can find.
Well, very interesting. Now, let me ask you this. Would a giraffe do as much damage to a tree as an elephant would? And are giraffes just as afraid of the bees as elephants?
So giraffes generally don't do nearly as much damage. And giraffes really are quite picky about what they will eat. So they have specific trees that they prefer. And when they eat, they are not bashing the tree around, they're not knocking it. So essentially, giraffes would be able to go and feed on those trees as well, without disturbing the bees sufficiently to cause the bees to swarm. So the other interesting thing is, very often if you watch giraffe feed, they will always feed upwind. So they will work out what the wind direction is, and then they'll always feed upwind. And the reason for that is that trees also release pheromones that say, I'm under attack, in inverted commas, and as a result, I'm going to do two things. One is I'm going to release a pheromone that tells other trees in the area, watch out, there's a, inverted commas, predator around. And the other thing they do is they push the tannin content of their leaves way up. And if you've ever had a really, really bitter cup of tea that's been brewing for a long time, that horrible bitter taste that you get is the tannins. It also takes all of the saliva out of your mouth. And so the trees basically will communicate with each other downwind. And as a result of that, the giraffes are not going to stay feeding on any one tree for a particular length of time or a long period of time. So much more selective and much more gentle in the way that they feed. Interestingly, they are also pollinators in their own right, giraffes. And they're the largest known mammal pollinator. And the reason for that is they particularly like knobthorns, and they'll stick their heads right into where the flowers are. And they obviously get pollen on the top of their ossicones, what look like their little horns. And they will then go to the next tree to browse some more, and that pollen will come off. And so that's how the tree's flowers are fertilized or pollinated. So they're not they're not the only pollinator of those trees, obviously, but they're one of the few large known mammal pollinators in the world. So yeah, so I don't know if that answers your question with a few diversions.
Well, it's fascinating whether it did or didn't. Can I ask you, have you ever witnessed an elephant being swarmed by bees?
No, I haven't. And it's quite interesting. I've done a lot of reading around the topic as well, and there are recorded incidences of elephants being stung quite badly, but where there have been witnesses, there has never been a recorded death from it. But no, I have not personally witnessed this happening. And one of the projects that I want to undertake in the new year is I want to actually try on some of our big trees, because here where I am based, the elephants are doing a lot of damage to our big trees. And I now, based on the work that Robin, Michelle, Lucy have done, I want to try and implement it here to see how it works. And then obviously we'll be able to observe it more. Because we'll put up camera traps so that we can film what's happening. So yeah, maybe in a year's time I might have a different answer to that question.
No, it's not practical to put a beehive in every tree, but is there like an ideal spacing between the hives and trees that would give protection to all the trees in that area?
Yeah, so basically they say that the minimum distance between trees, I'm sorry, I don't know what this is in feet, but is 7 meters, which is quite a distance. And obviously there is a combination, as you quite rightly point out here, of practicality versus efficacy. So essentially you're going to, there's also a cost implication to this, there's a maintenance implication. So I think you would have to assess the area in which you are working and how the bees react in your area, and then see and how the elephants react, and then work out kind of what an optimal, you know, an optimal distance is. Very often as well, you'll have one really big tree which is using a lot of the resources around it. So there won't be a lot of other trees that you would necessarily want to protect in close proximity. So you would protect that one tree. So yeah, it's not, there's also an aesthetic. I mean, this is another thing that's been discussed, is what about the aesthetics of this? You know, do people want to come to Africa and experience wilderness and now these beehives in the trees? But I think that's where also the practicality of modern day conservation, you know, as areas of wilderness are shrinking at an alarming rate, we have to do something. And so you've got to find that balance between aesthetics for your guest and practicality on the ground for conservation. So yeah, I think it's definitely, it's a balancing act. And yeah, I guess, yeah, that would be my answer.
Can you speculate for us maybe why the honeybees may be dying? Is it colony collapse disorder? Any information you can share with us?
So it definitely seems to be related in some way, shape or form to climate change. Also due to possibly the loss of many species on which they would habitually have fed. You know, as we urbanize areas more and more, so we remove their habitat. And so as their habitat shrinks, they just become less and less successful. I mean, there have been other things postulated that revolved around things like cellular communication was in some way interfering with their ability to communicate, because, you know, they have very specific ways of communicating, both by, they do specific dances and all sorts of things. And there was, and I haven't read any more on it, so I don't know whether it was kind of a flash in the pan, but that some of our modern technologies are starting to affect them as well. You know, like lights, for example, affect migrating birds and all these kinds of things. So I think, to the best of my knowledge, it's essentially the way that our habitats are changing, our seasons are changing, and combined with the loss of available habitat and food sources, that's actually starting to lead to their decline. But insects as a whole worldwide, not only bees, but all insects seem to be under some level of abnormal pressure. So, you know, there's a lot of talk, we talk about extinction rates and things are going extinct. Well, yes, that's true. And there is what we call a background rate of extinction. So that will always happen. Species will survive for a period and become extinct. When you start to talk about problematic extinctions is when that you start to drastically exceed that background rate. And some of the research that's been done in recent years has showed that if we were, they've looked at the number of species we've been losing or lost in the last 114 years. And they've calculated that if those were disappearing at background extinction rates, it would have taken 2,000 to 10,000 years to lose that number of species. We've lost them in 114. So clearly what we are doing to our environment is having a dangerously significant impact on, all of our biodiversity, fauna and flora. So yeah, it's the pollutants we put into the air. It's so many things that we do as humans. And yeah, I know that they've obviously just had this COP summit in the UK, and now everyone is looking at how do we stop this from progressing further than it already has, because the reality is it's starting to threaten humans as a species. I think we forget so often that we're part of the ecosystem, and it's only when things start to collapse around us that we start going, ooh, that actually affects me directly. So, sorry, it's a long answer to a short question.
I'm sure it's an even longer answer than we have time for. Let me ask you one last question. How the heck do you get those bees off the back of your spacesuit?
So you basically get one of your colleagues to come and brush them off. So yeah, they, for some reason on that particular day, I have no idea, they decided that sitting on my butt was a good idea. Interestingly, normally they're attracted, so bees are attracted to dark colors. So that's why the suits are white. They generally are much less attracted to white than they are to black, for example. Bees also respond very badly to strong smells. So you have to make sure if you're going to handle bees that you don't have your most expensive perfume on, because it's going to annoy the bees. And they hate the smell of cutting grass. So when you mow your lawn, try and make sure that you don't have any African bee species around you, because for some reason, and I don't know why, I'm sure there must be somebody who does, but they hate the smell of mown grass. And yeah, it brings them running out and they get very upset with you.
Thanks for that advice.
Yeah.
We need to
It's
hear.
funny because where I've got my beehive, there's a patch of grass and a very large area around it that the guys won't go anywhere near to mow, because they're like, no, this is not safe.
Well, great. Well, thank you, Lorraine, but I'm afraid that's the last question we have time for today. So I'd like to hand it right back to you for any closing comments you may have today.
Thanks, Rob. No, thank you very much for listening. And yeah, I hope that perhaps there was some food for thought, and yeah, things that perhaps we don't think about, we don't join the links or join the dots normally. So hopefully it's just given people a slightly different take on elephants, bees, and trees. Thank you.
Thank you, Lorraine. We appreciate you taking the time to present for us today. And I'd like to thank everyone who tuned in today. Join us tomorrow for our next Daily Dose of Nature. You can check out this week's lineups, including registration links, on our website at nathab.com/webinars. We did record today's presentation, and we will have the replay available on our website soon. With that, I will conclude the webinar for today. Goodbye, everybody. We'll see you next time.